I'm going to spend an extra couple of minutes on these warm-ups though, because see what happened was, there's a story. You guys just like cruise through, but my fourth period, they were very upset about how spicy these same base exponential problems were in the homework. And they're like, Mrs. Talbot, the one that you did was the easy one, but then they gave us super hard ones in the homework. You guys didn't tell me, you didn't say anything, but they told me. And I was like, oh crap, I should have done more of the warm-ups. So now we're going to do the rest of the warm-ups. That's what happened. Okay, anyway, so same base exponential. This is the easiest possible. This is the next easiest. What I want to do is I want to get these to both be twos. These are both threes, so I could cancel them. I want these to both be twos so I can cancel them. 32 is 2 to the what power? Fifth. Okay. And if you don't know that off the top of your head, that's totally okay. You can just do this. Make a factor tree off to the side and show that there's 5 of them. That's totally fine also. But when you start to do these same base exponentials, you'll start to memorize some of them. It's just going to happen. So 2 to the negative 2m equals 2 to the 5th. So I'm changing 32 to be 2 to the 5th on purpose because I want these bases to match. Once the bases match, I can cancel them. And voila, I can solve for m then. Okay, now number 3, you might argue that number 3 is harder than number 4. You might argue that number 4 is harder than number 3. I'm not sure because this is what I do for a living. So I don't think I have an accurate representation of how difficult things are, but okay. Let's discuss. 1/2 is 2 to the negative what? This is an old fact from Math 1, but what? Do you want me to show you why it's 2 to the negative 1? Oh. 1/2 is 2 to the negative 1 power. Does anybody want me to show them really quickly why it's 2 to the negative 1? Okay, so this is a little lesson I do in my Math 1 class to help people understand negative exponents. So this is a true fact. 2 to the 3rd is 8. 2 times 2 times 2. 2 squared is 4. 2 to the 1 is 2. Okay, now I'm going to look at the pattern over here. And what's happening is these answers each time are getting divided by 2. So 8 divided by 2 is 4. 4 divided by 2 is 2. That helps me with the 0 exponent. So I'm going to continue the pattern. What's 2 divided by 2? 1. That's why 0 power is 1. Okay, and then I'm going to extend this more into the negative exponents, continue my pattern. What's 1 divided by 2? 1/2. Extend it one more. What's 1/2 divided by 2? 1/4. Okay, but I'm going to write it like this. Okay, so what we do in Math 1 class is we establish this pattern and then we say, okay, take the reciprocal and change it to a positive exponent. So we're going to write ourselves a little note here. So you can look back at that whenever you get one of these that has a fraction in it, you can say, oh, Mrs. Talbot told me that was going to be a negative exponent. Now, why is it 2 to the negative 1? Because there's a little baby 1 on there that we just don't write. So you make this 2 to the 1, and then you move it upstairs, and it's going to become 2 to the negative 1. So let me say that again. First, put the little 1 on there, then move it upstairs and make it 2 to the -1. Okay, and now you have same base. Cancel, cancel. 3n equals -1. Now, all of these have come out to be fractions. That's not a rule. I don't know. Some of them are whole numbers. It's not a big deal. Okay, now this one is spicy. You have to actually think, oh no, what number, what base is the same between 64 and 16? So let me change that. Yeah, 4. Right, good. Connor got it. It's 4. Okay, so over here off to the side, I'm going to say 64 is 4 to the third, and 16 is 4 squared. Connor figured out the puzzle. The base of this one is 4. Now, you could also use 2. If you didn't think of 4, 2 will also work, and it'll get you the same answer. You're genius. You are a genius. Okay, so 4 to the third, -2n plus 1 equals 4 squared. So I took 64 and I substituted 4 to the third in for that. And I took 16 and I substituted 4 squared in for that. Do you think this is easier or harder than the fraction one? Okay, so now you can cancel out the 4s, and just as Gio said, this becomes distributive property. I should have done those all the other day. All right, now we're very quickly going to do number 6. Number 6 doesn't really require any thought or work or anything. It's wonderful. I like number 6. Okay, first, what type of a function is this? It's a rational function and it's a hyperbola shape. Okay, it's an asymptote. It has asymptotes, yes. Yeah, you're not wrong. Whatever helps you. So over here, I'm going to say a equals -4, h equals -2, k equals -1. I'm just putting them over here so that I can keep this up on the screen. Do you guys, are these okay? The a, h, and k? You see where those came from? Even though the negative's in the front, it goes with the 4. Okay, so this is vertically stretched by a factor of 4. Reflect across x-axis. Shift left 2. Shift down 1. Okay, now we do the asymptote thing. So shift left 2 means that I have a vertical asymptote at -2. Shift down 1 means that I have a horizontal asymptote down 1. The negative means that I'm going to make my hyperbola here and here, and the 4 doesn't really affect our graph because we just swing it anyway. It means that it's going to be closer to the asymptotes, but you know, good enough. Okay, next thing we're going to do is the resource page in here. If you could find it, it's 3.1.2 resource page. Okay, I am supposed to do 15 through 18 today. There's absolutely no way that's gonna happen. We probably will finish the resource page in 15 or 15 and that's it. It's totally fine because Monday only has 2 problems, so whatever we don't finish today will be Monday, not big deal. You do have homework. I know you have a special weekend, but I just want to tell you, even though I don't finish the lesson, there's still homework, but I don't actually plan on stamping on Monday anyway, because I can't stamp, because I won't finish today's classwork, and it'll bug me to stamp that box. So, you do have homework, but I probably won't stamp it until Tuesday. Just so you know. I didn't plan that for homecoming. It's really just because of the CPT time. I'm not that nice. I'm not mean either. It's only 4 problems. Okay. Homework is 25, 26, 32, and 34. And here's my joke. It says procrastination is a dish best served eventually. It's true. It's true. It is a dish best served eventually. All right, resource page 2. Okay, so we have some weird cases here. These are inverse problems. These all have something weird about them. Every single one of them, these 3. If we can finish these 3 between now and 9:10, I'm going to be ecstatic. It's going to be great. I'm going to be super happy about it. Okay. So this is weird inverses. Okay, so I have my original here in graphed and the equation. And the first thing I'm going to do is write the steps of the original. Okay, so if I plug a number in here for x, for order of operations purposes, what would I do to it first? Yep, multiply by 0.5, beautiful. And then I would add 3. Okay, you guys are like, yeah, so what makes this weird, Mrs. Talbot? I don't understand. Okay, now I'm going to get these points off of the graph, put them in a table. So this point is -6, 0. This point is -4, 1, 0, 3, 2, 4, and 8, 7. Yeah. Do you guys see where I got the points from? Just these dots here. Okay. That's about as much as we can do for the original. Now I'm going to switch to red. Okay, we can start with the table. That's easy. Oh. 0, -6. I think it's really awkward that CPM decided to make these graph paper go out to 9. Why not 10? Why 9? I don't know. Do you guys remember from Wednesday about the line of reflection? Do you guys remember the equation for the line of reflection? Y equals X, beautiful. And that makes sense because we are reflecting our table. So we're reflecting across Y equals X. I'm going to throw that in every single time, so you know. Just going to get in the habit of doing that. Okay, nothing weird's happened so far. I told you these are weird inverses. There's nothing weird that has happened yet. So if you think that this is all going just fine, it is, kind of. It is. Okay, now let's do our inverse steps. This is where the weird is going to come in a little bit. So my first step for the inverse will be subtract 3. And then divide by 0.5. Okay, and that's where the awkwardness is going to come in. I think you guys had a situation like this in your homework. So y inverse equals. Okay, every time I write an inverse, I want to start with x, subtract 3, divide by 0.5. Okay, this is not really an acceptable final answer. It's gross. Okay, I don't want to even actually have it on my paper. It's so bad. What I want to do instead is say, okay, let's be smart about this. Instead of dividing by a half, what else can I say that is better than division by a decimal? Division by a decimal is like 2 negatives. What can I say instead of that that's the same thing? Connor? But yes, multiply it by 2. Okay, so I'm going to take this step. And I'm going to lightly cross it out here because I don't want to use it. Okay, so now x, subtract 3, and then no, multiply by 2. And this ends up being 2x minus 6. Now I want you to look back at the line that we drew, the red line. It does not make more sense. The y-intercept is -6 and the slope is 2. So this is your official warning. If you have division by a fraction or decimal, change it to multiplication and flip it. Keep, change, flip. You guys know what I mean by keep, change, flip? Like dividing by a fraction, change it to multiply and flip. Okay, so did you have this in your homework with the One half of the, yeah, okay. Mrs. Talbot, why didn't they put that problem after tonight's? I don't know. I don't know. But if I go work for CPM, then I can't work here. And that would be sad. Okay. What time is it? Okay, I'm going to be able to do it. Next weird inverse. Okay, we're learning about PEMDAS. It's really important. There's some people who are still learning it. Parentheses first. Yep, add two. Yes. Yes. You guys know how to get the table of the inverse? Just flip it. Yep, just checking. That's awful. That's the worst thing I've ever. Wow. Okay, so for next question is what is the shape of the inverse of a parabola? Sweeping parabola is really not that shocking once you think about it. Because if you think about the equations of them, the x and y are flipped. That's exactly what an inverse is, the x and y being flipped. Okay, what makes this weird? We have not done that part yet. Can anyone already anticipate what the weirdness is going to be? If not, it's okay. Okay, so let's practice writing our thing here. So add 6. Divide by 3 on everything. Square root everything. Subtract 2 on everything. Okay, what shape is this? The thing I just wrote. Square root. What does a square root look like? Half a sleeping parabola. Correct. Okay, so just like when you square root both sides of an equation, when you inverse square root, what do you need? Plus or minus. Inverse of this really is 2 functions stuck together, unless you want to write it in sleeping parabola format. So for us, you're going to notice that a lot of the CUDA worksheets and things are not going to have parabolas on them because they just can't bend their brain around it not being a function. So when we do these with steps, whenever you write square root as one of your steps, you have to plus or minus it to get both pieces. Okay, last one. Flip this over. Trust me, it's not bad. Trust me. Trust me. Please trust me. Trust, have trust. Okay, it looks terrible, but this, I want us to attempt to write the steps real quick in our heads. What would I do first to the x? Yeah, maybe, but what about this x? I can't do 2 things to x's at once. This is a pre-calc inverse problem. In this class, we will not find the inverse function. The only thing we're going to do is to make the table and flip the coordinates and graph it. So, too many x's. In this class, we won't really do it when there's multiple x's in a problem. Doesn't mean it can't be done. It's like when you were told that you couldn't square root a negative. If you could totally do this, you're just not there yet. It's okay. Okay, so just take the last 2 minutes, flip the table, sketch the picture, and then you're done. Hopefully it will be symmetric on y equals x still. I think it looks like a butterfly or someone doing yoga. A
maybe a butterfly didn't know this.